All right, number 5, we're going to find our local extrema, our local minimums and maximums. I already gave you the derivative again, and so we're just going to set that equal to 0. And you have to think about, where is sine equal to 0? Well, sine is equal to 0 at 0, and sine is equal to 0 at pi. And so if we solve for t, we're going to divide both sides by 2. T is going to be 0, or t is going to be pi over 2. All right, and so we're looking between values. When we do our number line, we're looking between values between 0, not including, and pi. So we have to throw out this value because we're not going to include it. According to my domain, we're not looking at that value. So all we're looking at is really pi over 2. What's going on at pi over 2? And we want to look to see, is my function positive or negative? So this is my derivative. These are my t's. And I have a sine of 2t being my value. So I could pick a value between 0 and pi over 2. I'm going to pick pi over 4. And so it's 2 times pi over 4 is sine of pi over 2, which is 1. That's a positive number. And then I'm going to pick a number between pi halves and pi. So let's say 3 pi over 4. So 3 pi over 4 is pi, or let me see here. 3 pi over 4. I can't do math in my head today. Times 2 is 3 pi over 2. That's going to be a negative. And so here my function is increasing. Here my function is, and then afterwards it's decreasing. So at pi over 2, where t is equal to pi over 2, my function has a local maximum. So we have a local max at t is equal to pi over 2. Alright, number 6, we're going to use our calculator. So I'm going to punch in x sine of e to the x. It's not e to the x. And I'm looking at my window, I'm looking from -1 to 2, so I'm going to hit x min is -1, x max is 2. And then we're going to hit graph. And I'm going to go ahead and zoom in. So y, I'm going to say y min, let's say -2, y max, let's say as 2. There we go. And so we want to find, remember our y-intercepts, or excuse me, our x-intercepts are going to be where I have local extrema. And so I want you to notice between x is less than 0, my derivative is negative. That means my function is decreasing. Afterwards, my function becomes positive, and that means my function is increasing. And so we want to find, I have 3 x-intercepts. I have an x-intercept here. I have an x-intercept here. And an x-intercept here. And so I want to find what are those x-intercepts, because I know that below it this means it's negative and then it becomes positive. So if I have a negative slope to a positive slope, that means I'm decreasing and increasing. So at my first x-intercept I have a min. At my second, I'm going from positive to negative. My y values go from positive to negative. So then if I'm going from positive to negative with that x-intercept, that means I'm going up and down. That means I have a local maximum. And finally, my third, I'm going from negative to positive again. So again, I'm going from negative to positive. That means my function is decreasing then increasing. I once again have a minimum. And so let's find what those x values are. So I'm going to go ahead and clear that out. So a minimum, maximum, and minimum. So we have, let me get this back on again. So I'm going to do a second calc. I'm going to find the 0. My guess is probably going to be 0, 0. Right bound, hit enter, enter. So 0, there's my minimum. My next is going to be a maximum. Notice how my y values are positive, so now I have my, it means my function, if the derivative is positive, that means my function is decreasing, or excuse me, increasing. So there's my first, my left bound, right bound, hit enter. And so now we have 1.144. You can just truncate it. And so that's my maximum. And then finally I have a minimum. Notice that my function is now, my derivative is now negative all the way down here. That if it's negative, that means my function is decreasing. Oops, a little too far. So here I have my left bound, right bound. Now my function is increasing because my derivative is now positive. The y values of my derivative is positive. And so then I have a value at 1.837, again truncate. So I have a minimum at 0, maximum, I think I've said 1.7 something, or 1.2 something, and a minimum again at 1.8 something.